Hey everybody, welcome back to Talk Tensors. You ready for this one? We're diving into a paper that's looking at using forehead creases as a biometric identifier.
Oh, wow.
Yeah, so get this, those lines on your forehead could be the next big thing in security.
Really?
Yeah, and identification. We're going to unpack this paper. It's called Generating Realistic Forehead Creases for User Verification via Conditioned Piecewise Polynomial Curves,
Okay.
and figure out why it's such a big deal.
It's definitely a really interesting paper.
Yeah.
And it tackles a problem that's been kind of plaguing biometrics for a while now.
Okay.
The lack of large, diverse data sets.
So basically you're saying that to train an AI
Right.
to recognize something like a fingerprint,
Yeah.
or in this case, forehead creases, you need a ton of examples.
Exactly. The more varied the examples,
Yeah.
the better the AI can learn to recognize, those unique features in the real world.
Right.
But getting real world data, especially for something like forehead creases,
Yeah.
it's tough.
That makes sense.
It can be expensive, and there are all sorts of privacy concerns.
Right. So how did these researchers get around that? What's their big idea?
They're generating synthetic forehead crease images.
Wow.
So basically, they've come up with a way to create realistic-looking forehead creases on a computer,
Oh.
giving them a virtually unlimited data set to train their AI models with.
That's really smart. But how do they actually do that? I mean, creating realistic digital forehead creases sounds like incredibly complex.
It is. They use something called B-spline and Bezier curves, which are mathematical tools
Okay.
for creating smooth, complex shapes. You might not realize it, but these curves are used everywhere in computer graphics,
Interesting.
from designing cars to animating movies.
Oh, wow.
Yeah,
So they're using these curves to basically draw digital forehead creases.
exactly. And what's really cool is that they're not just randomly generating lines.
Okay.
They've actually taken inspiration from the way real forehead creases form, using those B-spline and Bezier curves to mimic the natural placement and variation you'd see in a real person.
Okay, this is where it gets really interesting. I was reading about how they actually used a 12-zone map that doctors use for Botox injections to guide their process.
Yes, that's one of the most fascinating aspects of this paper.
Yeah.
By using that 12-zone map, they ensure that the digital creases are placed realistically across the forehead,
Oh.
just like they would form naturally over time. This level of detail is key to making the synthetic data truly effective for training AI models.
So to put it simply, they're creating these incredibly realistic digital forehead creases that can be used to train AI without all the limitations of real-world data.
Exactly.
That's a game changer.
It is. But to really understand the significance of this research,
Yeah.
we need to take a step back and look at the history of biometrics.
Okay, let's do it. I think a lot of our listeners might be familiar with things like fingerprints and facial recognition, but forehead creases is a biometric that's pretty new territory.
Yeah. It is. Research into forehead creases as a biometric identifier only began a couple of years ago in 2022, to be precise.
So this is cutting-edge stuff.
Yeah.
What were some of the early challenges that researchers faced?
The biggest hurdle was the lack of data.
Right.
Remember, to train a good AI model, you need a lot of examples.
Yeah.
But back then, there just wasn't a lot of data available on forehead creases.
Okay.
Especially not the kind of detailed, diverse data needed to capture all the subtle variations that make each person's creases unique.
Right. And this new research tackles that challenge head on by creating this whole library of artificial forehead creases for the AI to learn from.
Precisely by generating this synthetic data, researchers can now train AI models to recognize forehead creases
Yeah.
with a level of accuracy and reliability that wouldn't have been possible just a few years ago.
This is truly groundbreaking research. It's amazing to think that something as simple as the lines on our foreheads could be used for identification.
Right, and the potential applications go far beyond what we might initially imagine.
Okay, so we've got the backstory, we've got the problem, and we've got this brilliant solution using synthetic data. What are some of the methods they explored to get that perfect crease?
Well, they experimented with a few different approaches, each designed to create, variations in those digital forehead creases. One method they used was called control point diversity, or CPD.
CPD. What does that mean in plain English?
Think of it as subtly tweaking the shape of each crease.
Okay.
By adjusting those control points, they could create a wider range of crease patterns, mimicking the natural variations you see in real people.
So it's all about creating a data set that's as diverse as possible.
Exactly. Another method they explored was visual prompt diversity, or VPD.
Okay.
This involved applying different image transformations, like dropout and elastic transformations, to those synthetic images.
So they're basically distorting those digital forehead creases in a way that mimics real-world variations.
Precisely. It's like simulating the way creases might look under different lighting conditions or from different angles. It helps the AI learn to recognize those key features even when they're not perfectly presented.
This is so clever. So CPD is about tweaking the shape of the creases, and VPD is about simulating real-world distortions if they try anything else.
Yes, they also used a technique called unconditional diffusion. Now, this one's a bit more complex, but essentially it involves using a specific type of AI model called a DDPM to generate entirely new edge maps.
Edge maps. You're losing me a bit here.
Think of an edge map as the foundation of a crease pattern.
Okay.
It outlines where those creases will form and how they'll connect by generating new edge maps. They could create even more variation in their synthetic data set, going beyond just tweaking existing creases.
So they've got all these methods for generating synthetic data. Which one worked best? Or was it a combination of all of them?
That's a great question, and the researchers actually compared the effectiveness of each method. What they found was that while all three methods improved, the accuracy of the AI model combining them yielded the absolute best results.
So diversity is key. The more variation they introduce in the training data, the better the AI becomes at recognizing real forehead creases in all their unique glory.
Exactly. And this is where the real-world implications start to get really exciting.
Let's talk about that. Why should our listeners care about this research? How could this impact their lives?
Imagine a world where you can unlock your phone with a quick glance, even if you're wearing gloves or your hands are full.
Okay.
Or picture a world where border security checks are faster and more accurate using touchless forehead crease recognition.
Okay, I'm starting to see the potential here. It's not just about convenience, it's about accessibility.
Too.
Think about people who might have difficulty using fingerprints or facial recognition due to disabilities or injuries.
Right.
Forehead crease recognition could offer a more inclusive solution.
Absolutely. And because forehead creases are relatively difficult to alter or replicate, they could offer a higher level of security compared to other biometrics.
Wow.
It's like having a built-in security system that's virtually impossible to fake.
This is truly revolutionary.
Mm-mm.
And to think just a few years ago, this wouldn't have even been possible. The progress in AI and biometrics has been incredible.
It really has, and as this research continues to evolve, I think we'll see even more innovative applications emerge.
So we've covered a lot of ground here, from the technical details of how they generate those synthetic forehead creases to the potential real-world applications. But I always find it fascinating to explore the broader implications of research like this. What does this tell us about the future of biometrics and our understanding of human identity?
It's a glimpse into a future where our unique biological features could be used in ways we never imagined forehead creases. Once a simple aspect of our physical appearance are now being explored as a powerful tool for identification and authentication. It's a testament to human ingenuity and our relentless pursuit of innovation.
And it raises some profound questions about what constitutes our identity if our forehead creases can be used to verify who we are. What does that say about the nature of self and individuality? What's next?
Well, based on this research, we can imagine even more cutting-edge applications on the horizon. Let's shift gears into our novel notions segment and explore what might be possible.
I love this part. It's where we get to speculate a bit, push the boundaries of what's currently known, and explore those what-if scenarios.
Right. And remember, this is all purely hypothetical, but it's grounded in the research we've been discussing. So what if forehead creases could reveal more than just our identity?
Go on.
What if those subtle variations in crease patterns could potentially correlate with other factors like our health or maybe even personality traits?
Wait, are you saying my forehead creases could reveal something about my personality? That's wild.
It's a fascinating thought, isn't it? We already know that facial expressions can convey a lot about our emotions. What if forehead creases, which form over time in response to repeated muscle movements, could hold subtle clues about our underlying emotional tendencies or even cognitive ability?
Okay, now you're really blowing my mind.
Yeah.
But how could we even begin to study something like that?
Yeah.
It seems incredibly complex.
It would definitely require rigorous scientific investigation, but imagine the possibilities if we could establish correlations between specific crease patterns and certain personality traits or health conditions. It could revolutionize fields like psychology and medicine.
Yeah, it really is mind-blowing to think about like all that potential information.
Yeah.
Just like right there.
But it's important to remember that, we're still in the early stages of this research.
Of course.
There's a lot more work to be done before we can start making, definitive claims about forehead creases revealing our deepest secrets.
Right. We're not saying you can get a personality reading from your forehead creases just yet.
Exactly. But the possibilities are definitely intriguing, and who knows what the future holds.
Right.
Maybe one day we'll look back at this research and see it as the starting point for, a whole new understanding of the human body and mind.
For sure. Well, for now, let's bring it back to the paper we've been discussing.
Yes, let's ground ourselves in the present. This paper, with its focus on generating synthetic data, has already made, a significant contribution to the field of biometrics.
Absolutely. It's a game changer by overcoming those limitations of real-world data.
Mm.
They've opened up so many possibilities for forehead crease recognition.
And as we discussed, the potential applications are vast, from enhanced security measures to more inclusive accessibility solutions. This technology could have a real impact on our lives.
Yeah, I'm really excited about the potential for touchless identification. Imagine a world where you can verify your identity with just a glance. No more fumbling with passwords or fingerprint scanners.
It would streamline so many aspects of our daily lives, from banking transactions to accessing secure areas.
Definitely. And, for people with disabilities who might have difficulty using traditional biometric methods,
Right.
this could be a truly life-changing development.
Absolutely. It's about creating a more equitable and accessible world for everyone.
So what's next for this research? What are some of the key areas that need further exploration?
One area that's ripe for investigation is the development of robust anti-spoofing techniques. As with any biometric technology, there's always the risk of someone trying to fake their way through.
Right. We need to make sure that this technology is secure and reliable.
Exactly. Researchers are already working on developing algorithms that can distinguish between real and fake forehead creases using, sophisticated image analysis and machine learning techniques.
And of course, as with any new technology, there are ethical considerations that need to be addressed.
Absolutely. We need to ensure that this technology is used responsibly and ethically, with safeguards in place to protect individual privacy and prevent any form of discrimination.
Well, this has been an incredibly insightful deep dive into the world of biometrics and the fascinating potential of forehead crease recognition.
It's been a pleasure exploring this research with you and our listeners.
And for those who want to delve even deeper into the technical details, we've included a link to the full paper in the episode description.
We encourage you to check it out and continue the conversation.
Thanks for joining us on Talk Densers. We'll catch you next time for another deep dive into the world of cutting-edge research.